This is section 5 of our Shadows notes. We're going to discuss the triangle inequality theorem. So as we saw in the what's possible activity, the triangle inequality theorem states you can only form a triangle if the if the lengths of the two shortest sides add up to be greater than the longest side. The lengths of the two shortest sides must add up to be greater than the longest side. Okay, and again, this idea is true for all other polygons, not just triangles. And everything else we cover in this unit, the special shortcuts and stuff that we come up with, will only apply to triangles. We're going to decide what makes triangles just so special. Okay? But this applies to all. So, to practice using this triangle inequality theorem, let's look at example number 1. It says, state whether a triangle can be formed with these side lengths or not. So you look and you see we have lengths of 2, 5, and 6. What do you think we should do with 2, 5, and 6?
Add up 2 and 5.
Good. So check those lowest 2. So 2 plus 5. Okay, 2 plus 5, is it greater than 6?
Yes.
Yes. So your answer is yes. The two smallest sides on B are 2 and 3. 2 plus 3 is less than 7, so my answer has to be no. So on example C here, the two shortest sides are 1 and 4. Is 1 plus 4 greater than 5? No. So your answer here is no. When those two shortest sides equal, your answer has to be no. It has to be greater than. And on D, two smallest sides are 3 and 5. Does 3 plus 5 greater than 6? Yes. Okay. So that's just one part of exploring the triangle inequality theorem. The other part is, what if I only give you two side lengths? What is the possibility for the third? Okay, so I have a little website, okay, that is in Schoology. If you go, and you guys and gals in this room, you can just watch along if you'd like, or you can get into Schoology and explore this with us. So I'm going to open up this link here. So in Schoology, for the folder for today, there is a GeoGebra link, and it's titled Triangle Inequality. And so on your notes packet there, what is the length of the blue side supposed to be? 15. Okay, and what is the length of the green supposed to be? 4. Drag this down to 4. Okay, my triangle has disappeared. And so now it says explore what the lengths of the, did they call this yellow or orange? Yellow. What are the possibilities here? When am I going to form a triangle? When I get up to what? 11.1. Okay, so 11.1 is the smallest that the third side could be because, what's the difference between 15 and 4? Difference, 15 minus 4? 11, so I have to just be smidge bigger than 11, right? So at 11.1 I get a triangle. Now, how big can my third side be? Any guesses before I get there?
Wait.
So 18.9 works. And what doesn't work? 19. Because as soon as I get to 19, that's 15 plus 4, and I get that straight line going across down here. Okay, so my triangle, my third side length ranges then from that 11.1 to 18.9. Go back and write that in. So then, and we're not going to deal with decimals in the fact, but we're going to just use our less than and greater than signs. We know that the side must be greater than what? 11, but less than 19. Okay, so it must be between 11 and 19. Okay, it can't be 11 and it can't be 19, but it has to be between. Okay, and so we could write that as an inequality, 11 and 19. So if I don't have this slider tool website, what's the mathematics here? I have a side length of 15, I have a side length of 4. How could I go from 15 and 4 to this inequality on the bottom line? Yes?
So, like it can't be shorter than 15, but it can't be longer than 19.
No, my inequality is 11 and 19. So how do I get 11 from 15 and 4? You subtract. And how do I get 19 from 15 and 4? You add. So if you want to find the range, then we need to add the two sides you were given and subtract the two sides you are given. Going back to our notes here, or I don't know if we need to turn the page. Let's have a couple more examples. So my two side lengths here on example 2, turn the page in your packet. We have side lengths of 9 and 5. So what's the range of values for the third side? Okay, what do I need to do with the 9 and 5? I need to subtract them and add them. So then when I subtract, I know the smallest the side could be is 4 or 4.1 technically, right? And then the largest could be up to 13.9. Okay, so my range is 4 to 14. So then let's say my two given lengths are 5 and 8. So to find my smallest they could be, I can subtract them. The largest they could be, I'm going to add 5 and 8. So now my range is 3 to 13. My third side is x. It must be bigger than 3, but smaller than 13. So your inequality signs are both going to face this way. Go ahead and try C. Write down the answers you think C would be. Now let's check and see how you did. So we subtract 10 and 6. We add 10 and 6, so our range is 4 to 16. All right, so that concludes section 5 notes.